So this lecture is on node, topic, and message. So here are the definitions. A node is an executable program that performs one specific task and communicates with other programs using ROS. Uh, a node has can be two type. It can be either a publisher or a subscriber node. A topic, on the other hand, is a named communication on a communication channel in ROS. Nodes use topics to exchange data, and message is the actual data that is sent through a topic. Now, to show the relationship, we can see that when we open a Ubuntu terminal, and that may have one or multiple nodes, and as we execute it, then that node will send some information to a channel. So that information is called the message, and the channel itself is defined as the topic. And then another terminal, we can open another terminal with another node that can receive the information or message from the first node, and that is called the subscriber node. So what is actually happening here? The first node, which is the talker node or the publisher node, is publishing information or message, but it's not publishing the information targeting the second node, which is the listener node here. Rather, it's publishing that to a particular topic or a channel. And from that channel, the listener node is getting those messages or information. So there is an intermediate step between these two nodes, and that's how node 1 and node 2, they don't need to know who they are, or don't need to communicate each other. So actually node 1, which is the talker node, doesn't even know where the information is going, because it's just publishing it to a channel, and the listener node at the same time doesn't know which node it actually is coming. It only cares about the message and also the channel or the topic. So here's some key points to remember: is a node is a running program, not a terminal. So Ubuntu terminal is not a node. A terminal can actually have multiple nodes or no nodes at all. The talker node here is a like publisher node, and receiver listener node uh, is the subscriber node, and topic is the communication channel. Now, if we see an example of that, the talker node, we can have this comment and see how a node is created, and then we can also create another node, which is this one, and see how they communicate data in between them. And when we write this one, ROS2 run demo underscore nodes underscore cpp talker, it basically means I'm telling ROS run the example program named talker from the package demo underscore nodes underscore cp. So right now we are gonna be seeing this thing. We're gonna be seeing this thing in a terminal. So let's open this. So we open an Ubuntu terminal. So here we can first see what are the nodes available in our system so far. So let's write loss node list, and this doesn't bring anything. That means we don't have any node yet. But right now we will create our first node. So let's go to this one and copy this and paste. And as we press enter, we can see that something is happening here. So it's basically publishing a lot of data. The data is hello world, and we can see different instances, 1, 2 ongoing, like right now 16, 17. So it's continuously publishing data. So what's happening here, um, when we are executing this command line command uh, line ROS2 run demo underscore nodes underscore cpp talker, uh, a program is executed where it creates data, that is hello world, and it continuously creates data. So right now we should be seeing, like if we check again, like what are the nodes in our ROS2, we should be seeing that there is at least one node, which is the talker node. So let's open another terminal. For that, another terminal, and then let's write the same thing here, list. And as we can see, like here we have another one a node, that is talker. Now here one thing uh, is important, that this the information that the first node is passing, this is getting passed to a topic. So it doesn't need another node to receive that. So it's not targeting towards any other node, rather it's targeting toward a channel which is called a topic, and that's why it's keeping creating those information even though there is no one to listen. So let's try this ROS2 topic list. So as we can see, like we are seeing here what are the topics, and we can see that there are three different topics. One is chatter, one is parameter events, another is ROS out. So as we created this node, or as we executed this node, by default we are creating this channel or this topic which is called chatter. So what are the other two topics? These two topics are actually by default created by ROS. The first one is to track the parameters. So this guy, this file, this command line, inside it will have a program that might have a lot of parameters. So as the program runs, the parameters might change. To keep track of those changes or parameter changes, this channel is created, which is the parameter event. So this is by default created by the ROS, and another one is the ROS out. So if we see that here the message that we're actually conveying, or the topic is actually hello world, but as we see that it's actually an ongoing process and incrementally providing us data, one to say n number of things, like it's go ongoing. And this logging, say one instance, hello world 5, hello world 6. So these instances are stored or taken care of by this channel ROS out. So this is useful for debugging. Say there is an issue with a particular instance, and we can go to ROS out this channel, and then we can sort out what is the issue. So if everything was taken care of by one single channel, it would have been difficult for the debugging process, and also to like understand the parameter changes and stuff. So that's why instead of one channel, we can see two more channels along with the chatter. Okay, so that said, like we can create another node which can actually listen to this. So the first one is talker, and we can also see, so from the other terminal here we have this talker, uh, this talker node, like providing us all this, publishing all these messages, and we can then execute this line. This will create another node. So if we press enter, and then we can see that Yeah, so this is listening. This is right now in the listener mode, and then this is said, I heard hello one. So this it started listening from like 306 instance. So from hello world 1 to 305, those instances it has no clue because it was not connected. Those every information was passed to the channels, and then as we connected this or executed this new node, it started counting from this and connected to with this one, and this will keep going. Like it's kind of understanding like or communicating with the with node one via the topic, which is the chatter. And yeah, so if we open a third terminal, so here like so far we have opened two terminal and we have executed two different commands or two different nodes, and that's why each terminal is having one node each. And then if we have another terminal and then let's do it again, ROS2 node list, and then this is gonna have this two nodes, listener and talker, because we have executed two nodes, and right now therefore we have two different nodes. And also we can also see the topic uh, topic list. Yeah, so we have the same number of topics, the same exactly same topics, because we didn't generate a new topic. So these are all getting all are sufficient to get the required information and perform the communication. So we don't need to create another new topic. So yeah, so that's how this thing works. So this right now, this method, this key point makes more sense. That says like a node is a running program and not a terminal, basically. So we had here three different terminal, but two nodes, and in our example, and multiple nodes can run in the same terminal. So we didn't try that, but we can also execute two different commands or two different program in this under the same terminal, or multiple nodes under the same terminal. And nodes can also run without any terminal. There might be no terminal. For example, the third one that we had, this one we had no we had one terminal, this third terminal, but there is no node running, and that's why we can see there is just two different nodes, even though we have three terminals.